Good afternoon. Today we're going to be doing L'Hopital's rule. It's one of my favorite rules in calculus. First of all, it has a great name, L'Hopital. And second of all, it's extremely useful. So this rule doesn't fit nicely into any of the sections that we do because it actually takes us back to limits. It takes us all the way back to the beginning of our year when we were doing limits. But unfortunately, or fortunately, whatever the case may be, you need to also know derivatives in order to use this rule. So it's kind of an application of derivatives, but it fits more logically into our section on limits. So what we're going to be talking about is we're going to be talking about indeterminate forms. And if you go back to the beginning of the year, we talked about indeterminate forms when we were evaluating limits. Indeterminate forms were forms of the nature of 0 over 0 or plus or minus infinity over infinity. We ran into these in a few different circumstances. We ran into them in problems like the limit as x approaches negative 1 of 2x squared minus 2 all over x plus 1. And you might remember what we did with these. Remember, our first option when we do limits is always simply to plug in. And so when we try to use direct substitution here, it should be obvious to you that we get 0 over 0. When we plug in the 0 for x in the numerator and the denominator, both of them go to 0. So we have to do something else. And you might recall what we did back at the beginning of the year, and this was kind of torture, I know, back at the beginning of the year. You didn't even realize what it was you were doing, but we would factor this, and then you would cancel things out, and you would get excited because then you could use direct substitution. We would always work until we could do direct substitution. This would be 2 times negative 2 or negative 4. We did this in a few different scenarios. We did it even with problems like this. We did it with problems approaching infinity. And we didn't really use algebra in this case, but what we thought about in this case is, oh no, when I plug in, this is infinity over infinity. There's my indeterminate form. That's my infinity over infinity. And what we realized was that this was talking about what we call a horizontal asymptote. Limits as x approaches infinity are horizontal asymptote. And in this case, this limit would go to 3/2. So we looked at those. You can go back into your notes way back when and take a look at those if you would like. But we looked at some problems where we saw indeterminate forms. This L'Hopital's rule is actually, it was actually discovered by a Swiss mathematician called Johann Bernoulli. And the Bernoullis did a lot of amazing things. If you want to have a nice little history lesson, you can look at what they did, but you probably don't. But L'Hopital has a better name, so we call it L'Hopital's rule. He's a French mathematician, and he wrote one of the first textbooks on differential calculus. And here's what L'Hopital's rule says. L'Hopital. Take it to the hospital, baby. Take it to the hospital. L'Hopital's rule says this. Says that if the limit, as x approaches a, of f of x over g of x, so we have a numerator and a denominator, yields an indeterminate form. An indeterminate form of 0 over 0 or plus or minus infinity over infinity. Then we can do something kind of cool. We can take the limit of both the top, the numerator, and the bottom, the denominator, and try to use direct substitution. So the limit as x approaches a of f of x over g of x, if that yields an indeterminate form, that is equal to the limit as x approaches a of f prime of x over g prime of x. To use L'Hopital's rule, you must show that there is an indeterminate form first. Don't just go willy-nilly using this thing wherever you feel like. You'll get problems wrong. You must first show an indeterminate form. The second thing I want you to notice really quickly is a common error is for kids to make this the quotient rule. This is not the quotient rule. It's literally saying take the derivative of the numerator and divide it by the derivative of the denominator. It's a very, very useful rule, and it will allow us to solve limit problems that otherwise we could not solve. I'm going to show you a few examples today. I'll move fairly quickly through this because I don't want this video to be very long. We will look at some of these together when we return from break. Here's your first example. Your first example is the limit as x approaches 0 of e to the 3x minus 1 all over x. Notice immediately you want to try direct substitution. When you do, you get 0 over 0. So what do? Take it to the hospital. We use L'Hopital's rule. We show the indeterminate form, all right, and we say, hey, world, this is indeterminate. So I can use L'Hopital. So you want to make a note of that somewhere. You want to write L'Hopital's rule. And L'Hopital's rule allows me to say that this is the same as the limit as x approaches 0 of what? Of 3e to the 3x over 1. I took the derivative of the numerator, which is the 3e to the 3x, and I took the derivative of the denominator, which is just 1. Now can I use direct substitution? Yes, I can. And the answer here is just 3 over 1, or 3. E to the 0 is just 1. This is not a problem you could have solved before you watched this video. Right? We could not have solved this using any algebraic techniques. L'Hopital's rule is required for us to solve this problem. We can always also use L'Hopital's rule in a problem like this. You may recall doing a problem like this back in the beginning of the year in September, and you would rationalize this problem in order to solve it. But when you plug in here, remember we try that direct substitution first. We get the 0 over 0, which is an indeterminate form. And so what do? We take it to the hospital. We use L'Hopital's rule. L'Hopital's rule allows me to take the denominator of the top and the denominator of the bottom. The derivative, of the numerator, the derivative of the numerator here is 1 over the square root of 2 plus 2 times the square root of 1 plus x, and the derivative of the denominator is just 1. Now we go ahead and we plug in. This is 1 over 2 times the square root of 1 plus 0 all over 1, which is just a half, and that's our answer. So we used L'Hopital's rule. L'Hopital's rule can get more complex. We could certainly use it to solve some trig problems. And another interesting thing about L'Hopital's rule is you can use it more than once. In other words, you may need to repeat yourself. Sometimes you may need to repeat yourself. Sometimes you may need to repeat yourself. So let me show you 2 more examples. Did you like that, Joe? Okay, let me pause it. So 2 more examples for you. Here's the first one. Let's do one that uses trig. Example 3 is the limit as x approaches 0 of 2 times the tangent of x over 5x. This is an indeterminate form. If I plug in, and I know it's probably been a long winter's break, but if I plug in, the tangent of 0 is just 0, and 5 times 0 is also 0. So what can I do here? I can use L'Hopital's rule. L'Hopital's rule allows me to take the derivative of the numerator and of the denominator. And when I do that, what do I get? I get the limit as x approaches 0 of 2 times the secant squared of x all over 5. Remember, secant, I should write this limit, I'm sorry. Secant is just 1 over the cosine squared. And I know it's been a long winter's break, but this answer is just 2/5, and I'm done. So using L'Hopital's rule, I used it once there, but I used it with some trig. Let me show you one example where you need to repeat yourself more than once. L'Hopital's rule can be used multiple times as long as each time you show that you continue to have an indeterminate form. So here's your 4th example. Let's do this limit. This is the limit as x approaches infinity of x squared over e to the negative x. If we think about what happens when I plug these 2 things in, I have an indeterminate form here. This is an indeterminate form because both of these are heading towards infinity or 0. So this is an indeterminate form. Infinity squared is infinity. E to the negative infinity, well, that's just 0. So we have an indeterminate form here. This allows me to know that I can use L'Hopital. But when I use L'Hopital, and I use it once, what happens when I use it once? What happens when I use it once is I pretty much have the same situation. that 2x is still heading towards infinity, and that negative e to the negative x is also just going to an indeterminate form. So what do? I use L'Hopital's yet again. I again have an indeterminate form, and so I invoke the power invested in me by L'Hopital's rule twice. And when I use L'Hopital's again, now I see that this makes a little more sense. Gosh, that was supposed to be a negative infinity. Maybe they won't notice that I messed up. I've never messed up in class before. That was supposed to be a negative infinity, wasn't it? Goodness gracious. We'll just fix that quickly. I'm sure no one will notice when they're watching the video. Do you think, Jewel? I think they might too. Don't notice that. It was supposed to be approaching negative infinity. I apologize. And it was going to be infinity over infinity. This problem makes a little bit more sense now. This is now e to the negative x down here. This is 2 over infinity, so this thing is just heading towards 0. Notice I used L'Hopital's rule twice. Not just once, but twice. One last example. Just remember that this rule only works if you have an indeterminate form of 0 over 0 or plus or minus infinity over plus or minus infinity. So sometimes you have to be a little bit creative. Your last example for the evening is the limit as x approaches infinity of e to the negative x times the square root of x. At first blush, you don't see something over something. But you're bright people. And because you're a bright person, you should recognize that I can make this the square root of x over e to the x. And that is an indeterminate form. That's an infinity over an infinity. As soon as I see that indeterminate form, I say to myself, aha, this is L'Hopital. This is the limit as x approaches infinity of 1 over 2 square roots of x over e to the x. If I rewrite this thing, this is 1 over 2 square roots of x times e to the x, or just 0. And that's my answer. These problems are usually fairly straightforward because they stand out. Whenever you have a limit problem, still what we said at the beginning of the year applies. If you have a limit problem, first you try direct substitution. So for your midterm, if you see a limit problem, first direct substitution. That's always your first option, and it's always your hope that that will work. The second and most likely thing you'll have to use is to check for an indeterminate form. And if it is, most kids actually prefer using L'Hopital's rule. L'Hopital's rule was only added to the AP exam, it was added to the Calc AB exam only 3 or 4 years ago. I can't remember which year. And they've asked it every single year since. It's not a difficult rule. It's just one you have to be aware that you can use, and it's super duper useful for you. On Classroom, I'm going to post a homework on L'Hopital's rule. This is the only topic this year that I ask you to learn on your own. It really is 2 skills that you already know. You already know how to take a limit. You already know how to take a derivative. And now we're just putting them together. So it's the only skill this year that I really don't teach per se in class. We will see examples in class, and I'll be happy to answer any questions that you have on the homework. The homework is going to be posted as soon as I get through with this, and I'll review it later this coming week. So the first week that we're back from break, probably either on Thursday or Friday. I don't have our schedule in front of me, I apologize. Either on Thursday or Friday, we'll do some review of L'Hopital's rule, and I'll try to answer any questions you might have. Have a wonderful new year. You guys are awesome. Thank you for your patience and indulging in my mistakes.